Well, first of all, I'll start off with the problem. This is a typical 1,000 megawatt coal-fired power station. Generates a million kilowatt hours of electricity per hour. At the same time, for the process of generating electricity, generates more than 2 million kilowatt hours of waste heat per hour, but it rejects up into the atmosphere using about 5 million litres of water per hour. At the same time, coming up the flue stacks, more than 1,000 tonnes of carbon dioxide emissions per hour. You multiply that by the number of 8,760 hours that you have in a year, and you get the picture for one power station. You multiply that by the number of power stations that you have in Australia, or indeed the world, and you're beginning to realise where the real problem is actually occurring. It is not credible that all that waste heat, water vapour and carbon dioxide and combustion emissions going up into the atmosphere is having no impact at all on the environment, on the climate or the weather. This inefficiency is also damned expensive. Normally when you're talking about the cost of electricity, it's usually at the commodity level. But of course, all of us pay electricity bills, which includes all those costs to get that electricity to you. We've begun to see that in New South Wales quite recently. $18 billion being spent over the current 5-year determination period of just shifting more electrons from the Hunter Valley into the city of Sydney. Across Australia as a whole, $46 billion is being spent right across Australia, which is about $12 billion more than the National Broadband Network, which everyone got excited about in the recent election.
Now, just a little bit closer to the mic, just trouble hearing me.
Okay. So this is, you don't see this on your electricity bill, but this is how the cost of your electricity is made up. Before the beginning of the determination period, network charges were about 40% of your electricity bills. They're currently about 50% and they're going to go up to 60%. By 2013-14, then the next 5-year determination period kicks in, and now we're going to be faced with another huge increase in electricity bills. Retail prices have increased by about 83% in New South Wales, and we're beginning to see that happen in other states as well. UTS did a study about a modest amount of decentralised energy could save in the region of $600 million a year and between $1.4 and $3.8 billion in capital investment, and reduce emissions by between 2.2 and 8.4 million tonnes per annum by 2020. But is there another way? This is Woking, so this is where I started. It's not an island. It's actually 25 miles south of London in the Surrey commuter belt. And yet it was able to go off-grid. Over a period of 14 years, it moved from being totally reliant on centralised power generation to actually supplying its own energy. The green dots represent the more than 80 decentralised energy systems that supplied that energy. A range of technologies, cogeneration, trigeneration, renewable energy, even fuel cells, and even streetlights that generate electricity. And that, over that period, 51% reduction in energy consumption, 44% reduction in water consumption, and 98% off the grid, so to speak. We also, at the same time, improved the energy efficiency of the housing stock, not just the public sector, but right across the private sector, 33% energy efficiency improvement. And collectively, that reduced emissions by 80% in 14 years. So yes, it can be done. Moving on to London, I was headhunted by London, Ken Livingstone, to set up and run the London Climate Change Agency. Haven't got time to go a lot of detail through this, but suffice it to say, we calculated that by 2050, something like 47% of what we were looking for would come from a decarbonised grid, but 53% needed to come from decentralised energy. I had lots of policy levers to play with in London, a city of 7.5 million, which is slightly bigger than New South Wales population. And so we had control of things like planning. So we were able to rewrite the London plan. We were able to put compulsory requirements for renewable energy in the London plan. And this showed the effect of the policy that we had. A whole range of technologies, including the London Olympics. I was part of the bidding team there. We put in a big decentralised energy system, in fact two. One for the Olympic Stadium and the sports arena around that, and another one for Stratford City. And yes, urban wind farms. You don't have to go to Copenhagen to see urban wind farms. You'll find them in London. This is the first one that went in Dagenham. There's now 3 in this particular area. And using going off grid, so to speak, so not supplying electricity to the grid but directly to consumers, in this case the full Dagenham plant are 100% renewable energy. Our outcome of our London planning policy showed that we were able to reduce something like 75% of new developments were able to deliver something between 10 and 20% from renewable energy was readily achievable. But by doing it by emissions rather than energy, that actually incentivized greater energy efficiency. So 40% CO2 savings come from energy efficiency, 13% from trigeneration, and 6% from renewables. Although half the trigeneration was actually running off of renewable fuel, so you can add that to either. And that achieved emission savings of between 30 and 40% over the UK building regulations. We developed offshore wind farms in the Thames estuary. This is a London Array. This is a 1,000 megawatt offshore wind farm. It's the largest wind farm in the world and supplies 25% of London's homes. We're also successful in removing the regulatory barriers to decentralised energy, which is why we've seen such significant growth in decentralised energy from not just from cogen and trigen, but also renewable energy. So, Sydney. This was quite a challenge from a standing start. Huge targets, 70% reduction in greenhouse gas emissions by 2030, and 100% from what they call local energy or decentralised energy. In other words, taking Sydney off the grid. So we're doing that at two levels. One is at the city-wide level, the local government area. We're doing that through the Green Infrastructure Plan. And the second level is for the city reducing its own emissions on its own buildings and operation on the show by doing principle. So trigeneration, well, first of all, we start off with cogeneration. You generate electricity, it generates heat. Instead of throwing it away at a remote power station, we can recover that heat and put that into heat networks, and through another conversion technology, we can convert hot water to chilled water to replace air conditioning and refrigeration. So the big thing that's driving electricity bills in New South Wales and Australia generally is air conditioning. The infrastructure has to be 6 times bigger than it would otherwise need to be for a few hours a day, for half a dozen days a year, to make sure that there's enough peak power to run air conditioning. So this is about moving off electricity and running it off the waste heat from electricity. And there are examples of what I call boiler in the basement systems, where standalone systems for standalone buildings, but they achieve nowhere near the high levels of efficiency when you connect a community together, whether that's at a city level or a town level or even at a shire level. So how do we go about actually doing this? Well, one of the first things we did was to get Ausgrid, the electricity distribution network operator, on board, and Gemina, the gas network operator, and we worked out where all the electricity was being consumed and in what intensity. Same thing for gas, for heating and hot water. The clever bit, I guess, is unbundling those figures to work out just how much waste heat could supply air conditioning as well as heating and hot water. And in a city like Sydney, air conditioning is by far the biggest energy consumer. So that gave us what we call our low carbon zones, 15 precincts. These are the ones up in the CBD, but also making sure new development, which will be the largest urban development in Australia, starts off green to start with. 24 different ways of doing it from around the world, and we identified the most cost-effective one, which also is the one that gives us the greatest reduction in greenhouse gas emissions. Capital costs, today's cost, $440 million, will save $1.5 billion in network upgrades and new power stations. Look at the cost of carbon. Energy efficiency is the cheapest cost of carbon abatement. But it actually comes in at number 2, just ahead of high-capacity wind and small hydro. Way up there, black coal with carbon capture and sequestration is 4 times more expensive if they ever get it off the ground. So what do they look like? These are various systems that you can see. That's a heat-fired absorption chiller that converts hot water to chilled water, if you've never seen one of those before. This is one of my projects in Woking, bolted on the side of a multi-storey car park. You wouldn't even know what it was, and yet that supplies electricity, heat and cooling to the town centre. Similarly in London, this is one of the trigeneration stations in the, supplying the London Olympics. And yes, we do need infrastructure, pipes in the road, pipes in the ground. And when you're doing that, and when you work out that this is the most economic project that you've got, that's the golden opportunity to put in a citywide recycled water network and an automated waste collection system. Trying to represent to people what emissions look like is always a challenge, so we kind of provided this 3D quasi-graphic, which shows what the emissions were. The higher that spike is, it's not a developer's dream, that's actually the annual energy consumption. And the redder it is, the peak or the intensity, predominantly driven by electric air conditioning. We looked at government targets, the 20% renewable energy targets against growth, and we found best case scenario that would be a 4% reduction in emissions, so nowhere near the 70% that we're looking for. However, implementing trigeneration, building connected to the thermal network will see their emissions reduced by 60%. So that's with trigeneration, that's without trigeneration. Moving on to renewable energy, we've split this into two sources, one for renewable electricity and one for renewable gases, and I'll come on to that in a moment. The areas that you see here, the blue corridor is a high capacity wind, the things that look like solar disks is solar thermal concentration, the red area is geothermal resource, we have quite a significant geothermal resource in Australia, and offshore wind and marine renewables. This shows you what goes to make that up. So if we were to capture every renewable resource that we have in the LGA, we could deliver something like 55% of our target. 45% would still have to come from outside the LGA. But we don't want to be responsible for increasing people's electricity bills by upgrading the grid. So we've developed a proximity principle that ensures that only new renewables outside the LGA are connected to the distribution network and not to the grid itself. Similarly with gas, very good resource in and around Sydney. With our proximity principle here is 250 kilometres, and the darker the orange and redder it is, the greater the renewable feedstock. And this shows you, quite interestingly, cow, pig, manure, waste, obviously municipal waste, broadacre crops, not energy crops, but just the waste from crops. In fact, all of this is waste. So you can run the City of Sydney off waste. And with the 250 kilometres gives us about 95% of the renewable gas that we need. So we're not going to generate electricity at remote locations. We're going to actually transport the gas into the natural gas network to gradually, over a period of time, replace natural gas. Putting that together with renewable electricity, 27% inside the LGA, 22% outside the LGA, and 51% for renewable gases to supply trigeneration. I haven't got time to talk about our citywide recycled water network. Suffice it to say that that's currently underway at the moment. Similarly, we have automated waste collection, which is new to Australia. First developed in Stockholm back in 1974, I think. There's about 80 cities around the world that now have this system, including a number of locations in London. But essentially, instead of collecting waste by garbage trucks, this is evacuated at 70 kilometres per hour under the streets and sent to a receiving station where just a simple waste collection vehicle comes along and takes that away to the advanced waste treatment system. Where this has been implemented in other cities around the world, there's been a 90% reduction in waste collection, transport movements and emissions. So how do you go about, you've got a wonderful idea, you've got a wonderful plan, but you need some customers. So we don't go and try and spend all sorts of resources on thousands of small customers and so on. So we unashamedly targeted the top 13 landlords in Sydney, so similar to what I did in London. These own more than 60% of the commercial real estate in the city, including retail and residential, the high-rise apartments. So we've got them on board first. We've also developed, copying from what was implemented in Melbourne, in Victoria, is now also law in New South Wales, and this is something that Queensland could do, but developing environmental upgrade agreements so that you can actually significantly reduce the costs by using this mechanism to actually energy efficiency, cogeneration, trigeneration, renewable energy, all those things, and indeed even water systems can be funded through this way. This halves the cost of implementing these technologies just by the council sitting in the middle, collecting that and putting in charge on the property. That de-risks the actual finance for the project. On the council's own buildings, 18% reductions in the first 2 years since I've come to Sydney, so that's in a period of 2 years that's been developed. Just led a contract for another 24% energy performance contract guarantee. That will take us up to 42%. And a whole range of other projects that we currently got underway. So trigeneration, we initially went out to a competitive tender. We established when the tenders come back, it would cost the council 3 times more if we owned the system ourselves than if we developed a private ESCO system. Because of the regulatory barriers you have in Australia and the fact that local government isn't recognised in the Constitution, I had to adapt this model. And essentially, so instead of forming a public-private joint venture company, which I did in the UK, we split those operations and the council will own the thermal energy network and will receive a use of system charge for that. And these are the first 4 precincts that are part of that. I won't go into any detail here, but this, for those of you who know Sydney, you'll probably recognise these areas. This is the work that we're doing on Green Square, which will be starting next year. It's a new development. We've taken over the old South Sydney Hospital site, which is a heritage listed building, and we've been able to reform. Planners have allowed us to do some reforming here. So similar to what I did in Woking, we're going to make that visible so people can come along and have a look at those 3 different technologies. I won't talk too much about the renewable energy programme that we underway. Suffice to say, we've got a $12 million PV programme, which we're about to let a contract on. These are some of the projects, including glass PV, and our LED street lighting, which we've just let the contract for. That will reduce electricity consumption by 51% for the Sydney's street lighting. Just quickly on transport, we've got electric vehicles, which are actually getting their recharge from solar PV. But we've also developed the larger vehicles, so we've now got these hybrid vehicles. And instead of using diesel, we use biofuel. So where do we think we will be by 2030? Well, if all of this comes together, we will hopefully see some offshore wind farms, similar to what most major cities around the world now have these, but also marine technologies. These are important because they're non-intermittent, so they can compete directly with baseload coal-fired power station, which intermittent renewables will need, and that's to avoid coal fires being in reserve. But coming across the city, we'd expect to see unshaded areas clad in PV, similar to what we've done already at Sydney Town Hall, and other buildings are now beginning to copy this. There are also opportunity for building integrated wind turbines as well. But if I can take underneath the city for the moment, this is the main hub of what's being initially natural gas, but eventually renewable gas. Generating electricity, recovering the heat from that electricity generation, putting that into a thermal network. That electricity will supply homes, it will supply businesses, it will supply offices, retail centres. That goes back to the Better Buildings Partnership. More importantly, the thermal network, which is part of the infrastructure that will actually go around the streets, will distribute that heat, and you'll come up in minutes here, you'll see that the thermal network will expand. The blue dots represent where the conversion of hot water to chilled water, so local buildings or groups of buildings converted into air conditioning to run those buildings. I'll finish there and hand over to the next speaker.